So we're going to review Unit 7 today, and this is on systems of equations. So first thing up here at the top of your Unit 7 chart is just systems of equations. So what I want to do is just talk about the things that you should know or need to know about systems of equations. So first thing is that what we're doing when we have a system of equations and we are asked to solve it, what we are doing is we are looking for the common solution or solutions. So what that means is that we are looking for where they meet. So where the lines meet. That's what we are trying to figure out when we are solving a system of equations. All right, now we learned 3 ways to solve systems of equations, and you can see them by looking below at this chart. One thing that we learned is by graphing. We also learned how to solve by substitution. And then probably most people's favorite was elimination. So those are the 3 ways that you can solve a system of equations. All right, not only do we have 3 ways to solve a system, we have 3 possible solutions. So 3 possible solutions. So what that means is that there's 3 things that can happen when we solve a system of equations. One thing is that it meets at a point, which means we would write an ordered pair. All right, the other thing that might happen is that there could be no solution. And then the third thing that can happen is that we would have an infinite number of solutions. So 3 ways to solve and 3 possible solutions to a system of equations. All right, so first up, let's look if there is one solution. All right, if there's one solution, that means that the 2 lines meet at one point. Okay, so what we're going to do is we are going to write the answer as an ordered pair. So write as an ordered pair. All right, what you can do if you are asked if a specific number is a solution, what you can do is just fill in the x and the y and check it to see if it works. So you can fill in the x and y to check. And you can check any single problem that you do. And any problem can be checked by filling in the x and the y and working it out to see if it's true. Okay, so over here, we have an example. So we have 2 options. One thing that we can do is just fill it in. The other thing that we could do would be to actually go through the problem and work it out, but I think filling it in is a little bit better. So let's just say that the question is 1, -3 a solution to this system of equations? Well, if you think about what you know about ordered pairs, this is the value of the x and that is the value of the y. So what I'm going to do is I'm going to go down here to this first problem, this first equation right here, and I'm going to fill in 1 for the x and a -3 for the y. So what I'm doing is I'm replacing the x and the y with the 1 and the -3. So if I fill this in with a 1, remember that doesn't become 21, it becomes 2 times 1, so that's going to be 2. And if I fill in this with a -3, 3 times -3 would be -9. And the question is, does that equal -7? And yes, it does. All right, so we know that this point is a solution for this line. So now what we need to do is check and see if this point is a solution for this line. So again, I'm going to replace the x with a 1 and the y with a -3. So when I fill in this with 1, Again, it doesn't become 41, it becomes 4 times 1, so that's 4. And then if I replace this with a negative 3, then I'm going to have minus a negative 3 equals 7. So what we want to know is if 4 minus negative 3 is equal to 7. Well, we remember hopefully from previous years that becomes 4 plus 3. So 4 plus 3 is 7. So yes, that one works in that problem as well. So is this a solution? Yes, it is. All right. All right. I just have this little graph just to show you that, let's say we graphed a line and it went just like that. It doesn't really matter. I just made it wherever. And then we have another line that goes just like that. What we're doing when we have one solution, that is saying that those 2 points met, or sorry, those 2 lines met at the same point. That is our solution. So when we have a problem like this, that is your solution right there. All right, next up. How could you get a problem that has no solution? Well, if you think about it, if we're trying to figure out where the lines meet, what happens if the lines don't meet? Well, that's how you get no solution. So on this graph, let's just say that we had one line's right there, the other line is right there. If the lines are parallel, they're never going to meet each other. They're never going to intersect. They're never going to cross or meet at a point. So in order to get no solution, the lines must be parallel. So I'm going to say actually that the lines will be parallel. So if you graph your lines and you get a pair of parallel lines, then you know that the answer would be that there is no solution. All right, so the question is, what if you work it out? What if you weren't doing this on a graph? What would happen on a graph is that you would end up with a false statement. False statement when solving. All right, so what's going to happen is that you're going to work out your problem, the variables are going to cancel, and you're going to be ended with something like 3 equals 0. All right, what do we know about this? We know that 3 does not equal 0. So if you get a statement that is false, this tells you that there is no solution. We'll talk more about that when we get to the back. All right, the next one. How are you going to end up with an infinite number of solutions? So again, if we're looking for where the lines meet, and we have more than one solution, there's only one way that could happen. Because we know that if we were to draw a line on the graph, the only way that another line would hit this line more than once would be if it is the same line. So, in order to get an infinite number of solutions, you are going to have the same line. So I'm going to say lines are the same. All right, let's say you're not graphing. If you're not graphing, how would you know that you're going to have infinite solutions? Well, what's going to happen is the exact opposite of what happened up here. When it's no solution, that's because we solved and got a false statement. When you're solving, if you end up with a true statement, then you know that you'll have infinite solutions. So a true statement when solving. So just to show you what that might look like, let's say you're going through and you're working out the problem and you end up with 7 equals 7. Or let's say you're going through, you're working out the problem, and you end up with 0 equals 0. Well, both of those are true. So if you get something like this, then you know it's a problem that has an infinite number of solutions. All right, let's continue on to the back. So now we're actually going to solve. So 3 ways to solve. Graphing was the one that we learned first. Most people like graphing. The problem with graphing is that you really need to have a graph. So what we're going to do, the steps that we're going to do, step number 1 is we are going to graph both lines on the same coordinate plane. All right. Then step 2 is if they meet, we will name the point where they meet. If the lines are parallel, it would be no solution. And then if the line ended up being the same line, that would be an infinite number of solutions. So we're going to graph both lines, and then we are going to name the point where they meet, if they do. So name the point where the lines meet. Where the lines meet. All right, so I'm going to give you an example, and I'm going to use 2 different colors just so that you can see which problem I'm doing each time. So let's say that our first equation is 3 has x minus 1. And let's do y equals negative x plus 4. All right, so step 1 says that I need to graph both lines. So I'm going to do the pink one first. So remember from our previous unit, the way that we graph is we start with the y-intercept. So I'm going to start at negative 1, and then I'm going to use the slope to rise and run for more points. So I'm going to go up 3 and over 2, up 3 over 2, or I could go down 3 and left 2. Now, when I draw the line to connect these points, I want it to go all the way across the graph because I have no idea where in the world these 2 lines might meet. All right, so now I'm going to graph the second line. So again, we start with the y-intercept. This y-intercept is at 4. And then we're going to use the slope to rise and run for more points. So if the slope is negative 1, that means up 1, left 1, or down 1, right 1, down 1, right 1, down 1, right 1, and so on. So now I'm going to draw that line, and you can see that these 2 lines met right here at this point. So the solution to this problem is going to be the ordered pair for this point, which looks like 2, 2. So the solution would be 2, 2. All right, so solving by graphing, again, you're going to graph both lines on the same coordinate plane, and then you're going to look for the point where they meet. If they were parallel lines, it would be no solution. If they were the same line twice, that's when we have infinite solutions. So I'm going to pause this video and continue because I'm almost out of time. So part 2 will be coming up.